Hey, today is Cinco de Mayo. If time permits, it makes me feel like I should go home and whip up a batch of some nice authentic cheese enchiladas or something. Would that be nice for Cinco de Mayo? Mm. Whip up a little guacamole, some cheese enchiladas. So today and tomorrow, today this will be a four example lesson, and then tomorrow same idea. So we're going to learn the harder log equations today and tomorrow. So today's are all kind of the same flavor. I debated how much I wanted to throw into the mix and decided just settle on one new addition to the mix, and then tomorrow will be sort of the final push. So anyhow, let's get to it. So we have log base 2 of x minus 1 plus log base 2 of x minus 3 equals 3. So like the process is not new. You learned the process last week. The idea is that we cannot proceed if there's two logs on the left-hand side. So we have to do that thing, that word. We have to condense those two logs down into one. So you guys would remember, of course, that when there's a plus sign in between two logs, what do we use for condensing? Multiplying. Good. So this is going to wind up becoming a single log on the left-hand side. It's going to be a log with a base of 2. And I'm just going to write this down. And then before you jot it down, I mean, you can if you want to, obviously, but I'm going to talk about where it came from. So I'm going to put x squared minus 4x plus 3. And then we'll need to take a quick side trip as to where that came from. Might be a few of you that already are aware of what just happened, but I did a square square multiply double, and that's just going to be sort of an in the moment thing. So let me show you. Inside the two logs, we have x minus 1 and x minus 3. And again, if there's a plus in the middle, then we know we have to do times. So what that becomes, I'm just going to go off to the side here, is this x minus 1 times x minus 3, like that. So the condensing you've had to do in the past has been really rudimentary, like 4x squared or 4x times 2. Like, give me a break. But this is a math problem inside of a math problem. So when you see the arguments of the logs being multiplied together over here, then you realize that you've got to multiply them out like old school. So if you want to take the full 4 steps at it, we can. But in the future, if we can go a little quicker, it would be better. So there's x times x is x squared.
We need the following students to the office: Adlin Rutledge and Ryan Graff.
X times negative 3 is negative 3x. Negative 1 times x is negative 1x. And then negative 1 times negative 3 is plus 3. But you'll remember from other things we've done before that can be a quicker process. You can do that. I said square square multiply double. That's not what I meant. I multiplied the binomials in my head. So that's where the x squared and then combine the like terms in the middle minus 4x plus 3 came from. Do you still have any lingering questions as to where the white underlined thing came from? Great, because you'll have to do that on half the problems today. All right, then let's press on. So once we get it down to a single log, then what is the next thing we do? That's already by itself. Yeah, I mean, we would have, so I mean, this is the thing that we would have said we have to get by itself, and it already is. So we're green lighted to do something. What is that something? Say again? Nope. Whenever you get a log by itself, this is where you hit it with the water cycle, right? This is where you do the conversion, and you are now about to leave the land of logarithms and turn this into an exponential equation. So over and over again, it's always the same. And I mean always. It's a powerful word. We take this to the power of this equals this. 100% of the time, that's how we convert a single logarithm equation into a non-logarithm equation. So having said that, if I raise the 2 to the power of 3, what do I get? I get 8. So I say that 8 is equal to x squared minus 4x plus 3. And I'm going to scroll up in just a second, so make sure you're good to go. You generally don't want to try to solve log equations. What you want to do is turn them into exponential equations and then solve them from there. So I'm going to scroll up and away, leaving on the screen now only a quadratic equation, which we should be pretty adept at solving, I would think, by this point. All right, so fundamentally, now that it's a quadratic, what's our thinking? I don't want to move the 3. I want to move the 8 for sure. So like I'm going to subtract 8 from both sides like this. I don't normally show that step, but you don't want to mess that. You don't want to say something stupid like 11, you know? So we're going to say now that 0 equals x squared minus 4x minus 5. And we've got some different approaches we could take. We could take the quadratic formula because that always works, but we could also check for factoring. So let's see if we can make the shells work. It's perfect. X minus 5 and x plus 1 is perfect. There you go. And spoiler alert, all of your quadratics today will be solvable without the quadratic formula. So that's nice to know. So if you find yourself up against it, like, oh, I can't factor this, something, either you need to get better at factoring or something went wrong prior to that. But they're all going to come out nice like this. So we get two solutions. The first one is that x could equal 5. And the second one is that x can equal negative 1. Now, I alluded to this last week and never came up, but I kind of threw it in the mix so that it wouldn't be a shock to your system today. There is a chance that both of these answers work. There is a chance that one of them works and the other doesn't. Like the 5 might work and the negative 1 might not, or they might both not work. So those are the different scenarios. And how we're going to figure that out is we're going to take our answers and we're going to go back up to the very beginning of the problem, which is right up here. And I'm going to erase a whole bunch of stuff now on my screen just so I can get your eyeballs on what's important. And what's important are these two logs. You cannot have two things. This is probably worth writing down right now. You can't have a log of a negative. So that's undefined. And you cannot have a log of 0. That's also undefined. So the way we're going to test our answers is we're going to put them back into the original logarithms before we condense them. Those are the two things you need to know about logs, is that they cannot have negative arguments and they can't have 0 arguments. So if I let's start with 5. So x equals 5 was one of our solutions. So if I take 5 and I put it into where this arrow is pointing, 5 minus 1 is 4, right? So it passes the test for the first one. If you put 5 into the second logarithm's argument, 5 minus 3 is 2. That one also passes the sniff test, so we can put a box around x equals 5, meaning we're committed. That is a solution. You don't need to math it all the way out. You just need to make sure it's not going to break a law. The other solution that we had was x equals negative 1. And if you put negative 1 into where the first white arrow is pointing, what do you get for the argument of the log? You get negative 2, because negative 1 minus 1, if you put it where the little purple underline is at, that equals negative 2, right? Log of negative 2 does not exist. Therefore, negative 1 is not a valid solution. So when I submit my answer, Whether it would be on, if it was on a test, like a paper test, you would show it just like that. These are my two answers. You do not leave an answer naked. You do one of two things. You box it to say I've tested it and it works, or you cross it to say I've tested it and it doesn't work. No answers just flying around naked, okay? They get a box or they get a cross. So in this case, there's only one solution to this equation, and it's x equals 5. Got it? All right, next one. Log base 4 of x squared minus 5 minus log base 4 of 4x plus 7 equals 0. There are other ways to teach what I'm about to teach you, but I don't want to confuse the issue with I don't want to put too many things in your brain. I think looking back someday, a couple days from now, if you see an equation like this, then maybe that's the time to have a conversation about sometimes more efficient approaches. But that's where teachers get ourselves in trouble. So I'm just going to show you we're going to do this just like we did the last one. So because there's a minus in the middle, what are we going to condense with? Division. So we're going to condense this into a single logarithm with a base of 4, and the argument is going to be a fraction this time, x squared minus 5 over 4x plus 7. So remember, plus condenses using times, minus condenses using divide. And I mean, what it says in here for now is irrelevant because what we're going to do next gives no craps about what the argument of the log is. What do we do next? Yes, we convert it. So we're going to take 4 and raise it to the power of 0 and set that equal to this. And anything to the power of 0 always equals 1, right? So when I'm working the conversion here, 4 to the 0 power is just going to be 1 equals x squared minus 5 over 4x plus 7. So the conversion is complete. We no longer have to talk about logs for the next minute or so. We just have an equation. And in Algebra 1, I really tried to express to you the importance of the logic of C fraction, kill fraction, C fraction, kill fraction. So in an equation like this, before we really attempt to quote unquote solve it, should be attacked by multiplying both sides by 4x plus 7. Because what that enables us then to do is to kill the fraction. Whatever's on the bottom of a fraction, you should multiply by. Don't be like trying to analyze things, just C fraction, kill fraction. So on the left-hand side, when you multiply 4x plus 7 by 1, you of course just get 4x plus 7. And on the right-hand side, the x squared minus 5 just falls to the ground when you pull the bottom of the fraction out. And hey, guess what? We have another quadratic equation. And with quadratic equations, we should always 100% fundamentally say, I'm going to move all of my terms to where Big Daddy is positive. X squared is like, I am the important term. The rest of you come to me. So x squared is going to just say, I'm here, I shall not move, which means then by default that the 4x has to shoot over and the 7 has to shoot over. We want all of our like terms to go the way of the x squared. So having said that, we're left with x squared minus 4x minus 12. And as advertised, there's another factorable quadratic equation. Yep. And then the shells are going to be x plus 2 and x minus 6. And as always, if the factors equal 0 as a product, then one of them must equal 0. So this one would say that x has to equal -2. This one would say that x has to equal 6. So again, they're not as much answers right now as what I like to call candidates, like they're in the running. They don't get boxes or crosses yet because we haven't run them through the test. So I'm going to scroll back up and we're going to test -2 and +6. So again, all that matters here are the logs. So -2 is a candidate. +6 is a candidate. And let's see what happens. So it's all about just plugging in where these little arrows are pointing. And if you find a fail right away, then you don't have to test it a second time, right? One fail's all we need. So if you put -2 right into this little purple jelly bean, what's -2 if you square it? +4. What's 4 minus 5? Can't have it. X equals -2. Adios. Thanks for playing. But again, I want you to understand that sometimes they'll both work. You might take away from this lesson other sorts of ideas. Just all I can tell you is trust me, sometimes they both work, sometimes one of them works, sometimes neither of them will work. And that's just, we do our due diligence and test the numbers. Let's test 6. What's 6 squared? 36 minus 5 is 31. So it passes the first test, but we still have to test it again. One pass equals have to go again. One fail equals I'm done. So if you put 6 in the second one, it's pretty obvious that that's going to be positive something. We don't even really care what it is, but it passes. So x equals 6 can have a box. X equals -2 got the cross. So that's the lesson. And what I have now are 2 more examples just to solidify. So now you know what you need to know. We condense, convert, solve, test. Condense, convert, solve, test in that order. Log base 4 of 3x plus 7 plus log base 4 of x plus 1 equals 1. Step 1, condense. And will we condense with times or divide? Times. So it's going to become log base 4 of 3x squared plus 10x plus 7. And I'm not going to be unprofessional about this. I still think that as your teacher, I should go off to the side and just show you that we did 3x plus 7 times x plus 1. And if you work out the whole multiply, 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 combine like terms, the one term that usually gets the question mark is 10x. That's where I answer the most questions. Kids say, I still don't know where you got the 10x. And the answer is, well, it's from 7 times x is 7x, and 3x times 1 is 3x. And those add together to make 10x, right? What did I do?
It says 1 at the top equals 1, and then it says equals 3.
Oh, I don't know why I put equals 3. Thank you for that. So do you have, other than that, do you have any questions about the actual problem, not my brain fart? Everyone okay with the 3x squared plus 10x plus 7? Rad. Okay, so condense, convert, solve, check. What's next? Correct, conversion, right? So 4 to the power of 1 equals that. And 4 to the 1 is just 4. And that's it. Conversion complete. No more mention of logarithms while we solve this. We'll have to talk about logarithms when we come back up here in a minute. I'll just kind of clear the way. But when we come back up in a minute, all we're going to be focused on are those two logarithms to see what our candidates produce. All right, so help me solve this quadratic. I suck at quadratics. What do we do? Subtract the 4 gives us 3x squared plus 10x plus 3 equals 0. And once you get a quadratic set equal to 0, the options available to you are generally check to see if it's factorable. If not, use the quadratic formula. So this is going to be a shell of 3x and 1x. And I think by now you're good enough and you've seen enough math to know that putting the 3 over here is the smart play, right? Because it buffs the 3 to make 9, and 9 gets us right next door to 10. Okay. And it is a fraction. So we're not going to panic. We're just going to say, okay, the answers are x equals negative 1/3 and x equals negative 3. So the good news here, generally speaking, is that you can just sometimes often use common sense. So let's head up and check our answers, negative 1/3 and negative 3. So we have x equals negative 1/3 and x equals negative 3. So let's test negative 1/3 first off. Let's get the pain one out of the way. Erase a bunch of stuff. So if you put negative 1/3 where the little purple arrow is pointing, what is 3 times negative 1/3? Negative 1. And what's negative 1 plus 7? So this one passes. Put in negative 1/3 in the second purple arrow, or the second, I'll change it to purple. And what's negative 1/3 plus 1? If you're in debt to someone 1/3, but you pay them back 1/2, did you cover your debt? Then it's positive 2/3. It passes the second test, therefore negative 1/3. You, sir, can have a box. You passed my tests. Let's test negative 3. It won't take long to find a fail. Put it where the first purple arrow is. What's 3 times negative 3? Negative 9. You don't have enough plus to cover the debt. Negative 9 plus 7 is negative, so this one gets a fail right away. Therefore, negative 3 gets a cross out. All right. Yes, sir.
You show again how it got to right?
Yeah, sure. When one of your factors is 3x plus 1, you just have to always remember that what your goal is to make this equal 0. Like that's what quadratics are all about. And so if I want to make that equal 0, then I just say, hey, 3x plus 1, I need you to equal 0. And then if you watch yourself solve the equation, like subtracting 1 first gives you negative 1. And then if you divide both sides by 3, that's where the fraction comes from. Better?
Yeah.
Okay. All right, one more, okay, guys, and then we'll have some work time. Last one, log base 3 of 4x squared minus 1 minus log base 3 of x plus 2 equals 1. Condense, convert, solve, check. CCSC. So step 1 is condense, and we will use division condensing because of the minus. So our single logarithm is going to be log base 3 of a fraction. And always remember to put your fraction in the same order as the logs. That was a question that came up last week, was that like you don't have the freedom to put this however you want to. The division will set itself in the order that matches the logs. Condensing, done. Step 2, convert. And the conversion is just the water cycle. 3 up to the power of 1 is just 3. And then the right side is now going to just be the argument. In our Algebra 101 training, instincts kicks in. And what do? Multiply both sides by x plus 2. And the math gods are going to strike me down. I got away with it once, but I've got to atone with the math gods here. Last problem, I didn't put parentheses around these, and I really should have, since it's a double multiplier. So you should do that too. Protect yourself from the wrath of the math god. So that was my bad. And it helps in a case like this, especially because we're not going to get away with, in the last problem where this purple arrow was pointing, there was a 1. So it didn't really matter. Like it was stupid easy. Yeah, 3x plus 6. And I know it's probably beneath you to have this conversation, but that 3 needs to be distributed. So that's where maybe the parentheses would not only please the math gods, but also would help you. So we're going to wind up with 3x plus 6 equals 4x squared minus 1. And hey, guess what? We got a quadratic. Quadratic equations 101. Move everything to whichever side Big Daddy's going to be positive. So we're going to leave 4x squared alone. Minus 3x minus 7 equals 0. And sometimes factoring is a little bit harder than other times. And you'll remember this from our past, whether it was this class or the last class, that when there's a number in front that's not a prime number, then factoring can be a little bit more of a chore. And the reason is because what we don't know is, right, is it 4x and 1x, or is it 2x and 2x? We do know that the signs are staggered. They have to be to multiply to make -7. And again, to protect myself from bad math juju, I'll put my equal zeros back on there. Anybody find it? So you put a 7 and a 1 like this, which I appreciate. And then Kaysen has realized that if we go this route, that we have to switch the signs, because in my current layout, I get positive 7x minus 4x, which isn't the right balance. We want the heavier to win. So we're going to switch our plus and minus to a minus and a plus, and that shifts the dynamic. So Hugo, since you just learned this, what fraction are we going to get from this one?
Will be positive 7.4.
Nice job. So our candidates are positive 7/4 and -1. Okay. So I'm going to scroll back up. 7/4 and -1. And all I want to know is, do they make any bad things happen up here? So let's check 7/4 first of all. And as I say this a lot throughout the year, and it's not like a passive aggressive attack. It's just those of you with worse basic skills will struggle more with garbage stuff like this. So I'm sorry about that. If you put 7/4 in this little purple jelly bean right here, or that little oval, you got to do 7/4 squared, which is 49/16. And then you have to do 4 times 49/16 minus 1. And there's two kinds of people in this world. There are people that would look at this and already know that it would be stupid to keep going. And there are people that will keep going. Think about that first thing. Like, what's 4 times 49? a lot. And that's really what I was hoping someone would say. I don't even really give a hoot what it is. It's big. And when you divide really big by 16, can we all agree that the answer is greater than 1? And that if you take something greater than 1 minus 1, that the answer by definition is positive? So it passed the first test. And then the second one is stupid. If you put in a positive number and add 2, hey, guess what? Newsflash, you just get a bigger positive number. So 7/4 has passed our first test. Or both tests, excuse me. He gets a box. Let's test -1. Put -1 where the little purple egg is up there. What's -1 squared? +1 times 4 is 4. 4 minus 1 is 3. We have another pass. Put in -1 in the second, the little red egg. And what's -1 plus 2? -1 plus 2 is 1. And 1 is positive, and it passes. And we see in this case that both solutions can stay. The only thing we did not see in this lesson is 2 that don't work, and it can happen. I had a really hard time. My theory, I'll be interested to see if any of you disprove this. My theory is that with these particular flavor, these equations today are all in the same, they all look the same. And I'm starting to think that maybe these don't ever have 2 that don't work, but I'll be interested to see. I clicked through maybe 30 or 40 of them last night. That's what I do when I'm looking through Delta Math. I just hit new problem, and it shows me solutions. I can cheat like that. So when I see the answers, it kind of tells me, oh, watch out for one like this. Ooh, watch out for one like this. Got to be honest, I didn't see any in today's work that had no solution, but I'm not going to say that it won't happen. I just kind of think it might. But then starting tomorrow, we're going to see it semi-regularly. So if you have any questions? Your assignment is number 54, maybe something like that. It's on Delta Math. You're going to work on that for the next 10, 12 minutes. And then I am going to add on some more notes tomorrow. And then Wednesday will be a big work day. So you can get this one done as well as tomorrow's done. Okay. I'm thinking Thursday won't be fair for a quiz since I'm going to be gone tomorrow. So I'll bump the quiz. Are there any seniors in first hour? Okay. Because seniors, I got to wrap it up. With juniors, I can keep going for another 7 or 8 school days before we start wrapping up grades. So, yeah, no quiz this week, I don't think. It'll be early next week. Cool. Rad.